Okay, so here is the formula with those variables that we could plug in to determine the flow of blood. So F here is the flow of blood. When we look at the delta P, so here, delta P is the difference in the blood pressures like at one part of the vessel versus the other, and that is going to force that blood through. You'll notice that if this goes to 0, then flow stops. So it's the difference in the pressure that's driving it. And notice that it is directly proportional to flow. So we say that this is directly proportional to flow. R is peripheral resistance. And as it increases, it decreases flow. So we say that it is inversely proportional to flow. So it has an inverse relationship, or it is inversely proportional to flow. So let's talk about this peripheral resistance and what are some of the factors that influence resistance to flow. So this would be in your notes, resistance to flow. The first thing, and maybe the most important because it changes all the time, is the diameter of the blood vessel. You'll remember that veins tend to have a larger diameter than arteries, and that decreases their resistance to flow, which is important because they're under low pressure, right? So if you increase the diameter, like in vasodilation, right, you decrease the resistance. If you decrease the diameter, then you increase the resistance. And so we say that blood will flow in the path of least resistance. So that means that we can shunt blood to different areas of the body because there's just too much resistance to flow when we constrict these blood vessels to one part of the body. And when we open them up, then there's less resistance, and so it will tend to choose that path. And so this allows for the shunting of blood to different parts of the body. Okay. The second thing that influences this resistance to flow is blood viscosity. So that is how thick your blood is. And so you'll think back when we talked about blood, that red blood cells can vary, the amount of red blood cells can vary. And so as we increase the red blood cells, we get an increase in viscosity. And so, for example, this is why doping, blood doping, and EPO, specifically using EPO as a drug to enhance your performance as an athlete, can be very bad because it decreases your or it increases your blood viscosity, and it causes a resistance to flow. So it's going to be harder to get the blood to the different areas. The third thing is the length of the blood vessel. So as we increase that length, we have an increase in resistance. So this would be like as we grow up from children and become adults, big adults, and then maybe as we gain weight, if I was to gain like 50 pounds, then I would have a problem in that I would have to overcome this resistance to the blood flowing to those regions of my body that are new, right? So as we increase the length of the blood vessel, there is an increase in the resistance. And those are the three major factors in blood vessels that affect the peripheral resistance in the blood vessel.